All right, so a couple of things. First off, I did get your test graded finally. A few of you still have yet to take the test, but your tests are now on in the grade book. This week you will have a quiz on Friday, and then a quiz next week Friday. But you also, the majority of you have next Tuesday off too, because it's ACT day. So unless you're a junior, you got Tuesday off. So the American College Test. All right. You'll have to take when you're a junior. We are in your notes today. I believe it's on page 8. In number 1, I want you to graph those 2 lines. In number 2, I want you to solve those 2 lines by substitution. Okay. And then I want you to compare those 2 lines as to what you see, if you observe anything. And then in number 3 is a straight up reflection. Okay? Go for it. On the left one, it's got a slope of 2 and a y-intercept of -1. So that would be the left line. On the right line, it's got a slope of -1/2 and a y-intercept of 4. Said solve this one by substitution, so it's already solved for y. So I'm going to plug that in for y on the other side. 2/3 x minus 1 is then going to equal 2/3 x plus 2. If I subtract off 2/3 x from both sides, then I get -1 is equal to +2. And that's an equation, or that's a statement without a variable that is not true. So therefore, this would be a no solutions case. Some observations from both of those. Let's first observe here in number 1. In number 1, those 2 lines are perpendicular. And I know that because the slopes are opposite reciprocals. One is positive, one is negative. That's the opposite part. Two flipped over is 1/2. 1/2 flipped over is 2/1. So therefore they are reciprocals. And in order to be perpendicular, you have to be both opposite and reciprocal. You don't just get to be one. Okay? You got to be both opposite and reciprocal. Okay? My observation in number 2 is that those lines are parallel. Two reasons why they're parallel. First reason is the solution we got was no solution, which means that they don't cross. Okay? It was a false statement. Okay? But the real reason is because the slopes are equal. Okay? Slope on the left line was 2/3. Slope of the right line was 2/3. So those slopes are equal. Okay? Reflect the arrow over the line 1/2 x minus 2. Well, first thing we got to do is we got to put in the line 1/2 x minus 2. So that's the y-intercept of -2. A slope of 1/2 is up 1 and right 2. Or down 1 and right 2. When we reflect, we have to reflect parallelly. Excuse me, I said parallelly. I meant perpendicularly. Okay? We have to reflect perpendicularly. So if the slope of that reflection line is 1/2, what is the perpendicular slope to a slope of 1/2? -2. I need to be opposite, so it's got to be negative. And I got to take 1/2 and I got to flip it over. So the slope that I'm going to be dealing with, or the slope that I'm going to be reflecting in, is going to be -2. Okay? So now I'm going to take this green point and I'm going to go a slope of -2. That would be up 2 and left 1. That puts me right on my reflection line. So that did one of those. So I got to do one more to get to the point of where it's going to be. So let's call this point A. Then this would be A prime. If I call this point B, up 2 left 1, up 2 left 1. It took me 2 to get to the line of reflection. Up 2 left 1, up 2 left 1. This would be the point B prime. Up 2 left 1, up 2 left 1 gets me 2 to get to the line. Up 2 left 1, up 2 left 1. There would be the point C prime. One, 2, 3, 4 gets me to the line. 1, 2, 3, 4. And there's the arrow. Okay. Could have also used tracing paper if you had some. If you ever are running low on tracing paper, it's always up here in the desk. Yeah, you just gotta. That's a you call when you need some. We need some more. Huh? Good to go on that. All right. So Amanda was finding reflections, and she wondered, what if I reflect a shape twice over parallel lines? Okay? So what she's basically saying is she wants to take this triangle and reflect it over line N, and then reflect it again over line P. Okay? What do you think is going to happen? Okay? Because it'll flip on the first one, right? And then it'll flip again on the second one, so it should be back to normal, so it would have just been a translation. Okay? Makes sense? Let's see if you're right. Okay? Now, labeling our points is critical. Okay? On Friday's quiz, next Friday's quiz, and the quiz that comes or the test that comes after that, you're going to have all of these points labeled. Okay? All right? So, luckily for us on this one, we're dealing with horizontal and vertical. So I went 1, 2, 3 to get to B, which means I got to go 1, 2, 3 to get to B prime. I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to get to C prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to get to C prime. 1, 2, 3, 4, 5, 6, 7, 8, 9 to get to A prime. 3, 4, 5, 6, 7, 8, 9. Okay. So that was the first flip, right? One, two, three, four, five. 1, 2. So this would be A double prime now, okay? Because this is our second reflection or our second transformation. Okay. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 11. 6, 7, 8, 9, 10, 11. Was Daisy correct? Was it just a translation? Yeah? Yep. We just slid it literally to the right. I don't even know how many we slid it, right? 3, 6, 9, 12, 15, 16. There's a lot. Yep. How much? 28? That seems too many. Because what was this? This was 9.
Wait, where are you going from?
9. Well, so any point from A to A double prime. So that was 9. That was 18. Yeah, it would be 28 because it was 5 and 5. Yes, we're correct. My fault. Yep. So this is just really a translation. 28 spaces to the right. Okay. In number 2, the very first thing that I need you to do is I need you to move your point P. Okay? For some reason, in the copying process, point P got disconglobulated and moved off of where it should be. Point P should be at the intersection of the 2 reflection lines here in number 2. Okay? So first thing you need to do is you need to move your point P. Okay? Amanda's teammate says, what if the lines of reflection are not parallel? Okay. What's going to happen when we reflect EGF, triangle EGF, in letter V? It's just going to flip over, right? Okay. So, now, what's going to happen when I reflect in line V?
It will change, it will turn itself.
Kind of like flip it over, kind of like flipping a pancake, right?
Yeah.
Okay, so it's going to flip that pancake over there. Then what's going to happen when I reflect it in line W? It's going to flip that pancake again, right? Okay. Now, Daisy, you had said in the last one that it just would end up being a translation. Is this one going to end up being a translation?
Not one translation. What couldn't you do, like, translate right and then translate down?
That would still be one translation. Yeah. No, that's still one translation. Do you understand what I'm saying?
Yeah.
Like one, because we'll get to a problem like that a little bit later on, where I want you to move the triangle 4 to the right and 3 up, kind of a deal. Okay, so you're still thinking translation? All right, let's try it. Okay, so let's reflect it in line V first. So we went 1, 2, 3. 1, 2, 3 would be right there. So there would be F prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would be there. So that's going to be G prime. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8.
You're asking me if it was a translation I talked about, like, is it gonna look the same?
But you remember how the last one looked the same?
Yeah, that's, okay. Yeah, I'm gonna
Okay.
do that.
All right, well, let's see. Let's see.
I was
Clear on what I was saying? Okay. So, if I'm reflecting in a non-vertical line or a non-horizontal line, how do I need to reflect? But how? How do I reflect when it's not a vertical or horizontal line?
You have to do the slope.
What do I have to do with the slope?
You have to find the slope and then opposite or something.
I gotta get perpendicular, right?
Yeah.
Okay, we reflect perpendicular. Okay, so what is the slope of line W? What is line W's slope? 1. Because you rose 1 and you ran 1, right?
Yeah.
So up 1, right 1, up 1, right 1. That's 1 over 1. Okay. What is then the perpendicular slope to positive 1?
Negative.
Negative 1. Okay? Which means when I'm going to be going from my blue triangle to my finished product, I'm going to have to be going down 1 and right 1 at all times. Okay? Alright, because I got to be on that perpendicular to line W. Alright, here we go. We'll start with point G because it's the closest one to the line. Down 1, right 1, down a half, right a half.
Yeah, that's what it's like.
Okay, so then coming out the other side, right, we would go down a half, right a half, down 1, right 1. So G double prime would be right there.
Wait, what would you do? You said it again?
So because it was 1.5, down 1 and right 1, and then down a half, right a half to get to the line.
Oh, so you're just moving 3. Like, down 1, right 1, 3 times.
Because you got to double it. Yep,
Yeah.
it's got to be the same on both sides. Yep. Mm-hmm. You want to try it again on F prime? Okay. So F prime. Down 1, right 1. 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 So that was 5 to get to there, right? And then I got a half and a half to go yet. Okay? So if I get the half and a half to go yet, then I'm on the other side of that same square. So now I need to go 5. 1, 2, 3, 4, and 5.
Oh. So, if you're doing with halves, you can really just add them and then continue. Like, I can do 11.
The halves would cancel each other out. Yep. Mhm.
Yeah, that makes sense.
Mhm.
Because if you get to a half on the line, you just skip to the next. Like,
Go to the other side. Yep.
The
Mhm.
next square, and then you just.
Yep.
Down there, yeah.
So 1, 2, 3, 4 to get to that one. 1, 2, 3, and 4 to get to that one. So back to my original question. Translation, no translation?
No.
No translation. Okay. Rotation?
Rotation.
Okay. So now, when we're talking about a reflection, we're talking about a line that we're reflecting it in, right? When we're talking about a translation, we're talking about how far left or right we're moving it, how far up and down we're moving it. Okay? When we're talking about a rotation, when we're talking about a rotation, we're talking about two things also. Whoa, tap the brakes. Forgot to turn the pen on. So we're talking about which direction, clockwise or counterclockwise. Okay? And we're talking about how far we got to rotate.
Wait, so this is.
100% it's rotation.
Yeah, you just have like it rotated. The axis.
We're rotating at 90 degrees.
The axis will not because what do you're not gonna shape it that way.
It will. It actually will.
I'm so good.
You're gonna prove it here momentarily. Okay. So it's a rotation of 90 degrees because our GF line went from flat to vertical, right? So right there, that tells me that it's a 90-degree rotation. And which way did we go? Did we go this way, or did we go the other way?
Clockwise.
We went clock because we went this way, right? Okay, so that's clockwise. Okay, you all have tracing paper. The center of rotation is point P. That's why why I needed you to move point P.
Oh, see, yeah, it wasn't
Okay. Okay? The center of rotation is point P. Here is how you rotate something on that or on a graph like this. Okay? So what you do is you not only have to draw the triangle on your tracing paper, but you also have to mark point P on your tracing paper. Okay? So you should have your tracing paper out right now so that you can practice this. Okay? So you need to have your tracing paper that covers both the original triangle, EGF, okay? And you need that piece of paper to cover the triangle and point P. Then what you're going to do is, so you're going to trace out the triangle and you're going to lock in point P. You're going to take your pencil and you're going to set your pencil on point P. That's going to hold that in, and then you can rotate your piece of paper around whichever direction you need to go. Point P is the center of rotation. So you have to, yep. And now you can just take it and just move the piece of paper like so. Because you've locked, because your pencil is holding it in. She was probably doing her homework at the time when I said that she had to move her point P.
I thought it was the dot that says P. He said that was oh, you start right here with your tracing paper?
No, no. You got to be able to cover the triangle and point P.
Wait, how would you know that's 90 degrees? Or I know it's possible.
Okay. So what I would do is I would draw in like I would follow along with like a vertical line. You know what I mean? So like I would just put a little tick mark. I put a little tick mark somewhere in it. Okay? Yeah. On like one of the grid lines.
So like it's like 9. So like could you do like a it's
Sure.
and then like right here.
Mm-hmm.
If I do it on the corner.
Yep.
And do a full 220. Oh,
270.
got it.
270. Okay. For me, because I don't have a big enough piece of tracing paper for it, okay? So for me, I always go, okay, so I went up this many, and I went right that many. Okay? So when I rotate it, now, so this I went, so here, let's count. I went, excuse me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now if I rotate it over here to point F, now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then up 3. So I wrote it 90 degrees. Yep. So my L went 90 degrees clockwise. Okay. Oh yeah, tracing paper makes it much easier for you. I just don't have one that big.
You should get one this week.
I should, but
Or you could just use
I can just use maths.
then use bright enough. It has been like
You just get a really big piece of wax tape. I'm pretty sure that's what this is, right?
Pretty close, yeah. It's a little thinner than wax paper. Yeah. Okay. So consider what we know about rotation. So just so you know, another symbol for clockwise and counterclockwise are right here. Okay. So they will just kind of give you the direction that you're going instead of writing out the big long word. Okay. So if I were to rotate this in point A, we're not going to do all of these. Okay. If I were to rotate 180 degrees clockwise, for me, this red point here, because it's straight out to the left, would then rotate around and go straight out to the right. this blue point here, I went 4 out to the left and 1 up. If I rotate that around 180 degrees, that's going to be 4 out to the right and down 1. Green point here, I went 3 to the right and 3 up, which means I'm going to go 3 to the left and 3 down. Getting there. I went 1 to the left and 3 up, which means I'm going to go 1 to the right and 3 down. One left, 1 right, 1 right, 1 down. Excuse me, one left, 1 up. Okay. And I guess I didn't use. Now we'll use blue again.
Wait, so what did I do wrong? Why did I do this? Maybe there's one number. Oh,
What am I off by?
Are you looking?
I am not looking, no.
Oh, no, not you.
Yeah, that's right. You went in when you were supposed to go.
Yeah.
I went in when I was supposed to go out.
Yeah. No, that one was right.
Yeah,
Oh.
that was
That was like, and
It's,
then
it's the
that.
That one I went in when I was supposed to go out.
I think.
Yep. Yep. Yep, there it is. Yep. Now, does direction matter when we're rotating 180 degrees?
Yes.
No.
Well, no.
Well, let's see, because now this one we want to rotate clock or counterclockwise, right?
Yours don't think it does.
No, it doesn't.
No, it doesn't. You're just copying it, so something tells me it doesn't matter.
Does it matter?
It matter because it's a straight line.
No, it's the 180 degree part. Okay? Because it's 360 degrees to get all the way around a circle, right?
Yeah.
So 180
Oh,
degrees
no,
is
it does not
halfway
matter.
around, so it doesn't matter which way you go, you're still ending up at the same point.
Oh,
Okay?
yeah.
Right? What about
What it's gonna make
rotating
you do for-
360 degrees?
That'd be the same place.
It's gonna be the same thing.
So that's going to rotate it right back
Where you started.
to itself, right? So that's just going to map the new one onto the old one.
But then
Okay?
the next two are different.
I'd say, yeah, let's do that. So 90 degrees, if I rotate 90 degrees clockwise, then that's going to be, so I went 1, that's going to go here for 3, then angle, 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 angle.
Is the little line, little tail part of it?
Yep.
You rotate that.
Okay. Now if I go the other way, it'll look like that. So order matters when you're talking about rotations. Okay?
Got it.
For sure.
All right.
Is that the
For that one.
order?
Okay? So now let's talk translations. Okay? So this is how mathematics translates things. They give you a roadmap. What this is saying is you're going to be adding 4 to all of your x values and subtracting 3 from all of your y values. Okay? Just remember that on an xy coordinate graph, adding is to the right, because that's the positive direction. Subtracting is to the left, because that's the negative direction. Adding is going up in terms of the y's. subtracting is going down in terms of the y's. On a problem like this, the first thing that you have to do is you have to draw your original image. Okay? So I need to draw line or put in point A. Negative 2, 5 is right here, and I'm going to label it point A. I need to put in point B. Negative 5, 0, and I need to put in point C. Okay? Now that I have my original drawing, now I can move it. This is telling me that I'm going to be moving it 4 to the right and down 3. So each of my points goes 1, 2, 3, 4, 1, 2, 3. So here would be B prime. 1, 2, 3, 4, 1, 2, 3. Here would be C prime. 1, 2, 3, 4, 1, 2, 3. Here would be A prime. I'm listening.
Can you just, like, could you also just take all the original points and then do the math ahead of time? And then just redraw the shape with the new coordinates?
As long as you draw the first shape too. Okay?
Oh, instead, like, on the graph, it's like, that would be easier, or like, maybe more simple. I know, right? Like, just write out the coordinates.
Because later on we're going to get to multiple translations, like kind of what we were doing earlier. You know, we're going to have a translation, then a rotation, or a reflection, then a translation, and things of those natures. Okay? So in B, we're not going to do B, but we're just going to talk about it here for a second. What's my two movements of my triangle? Left 5 up 2. Okay. Minus 5 would be the left 5. Plus 2 would be the up 2 part. Okay. So you can move triangle Riz left 5 and up 2. Okay. All right. Let's take a quick peek at your homework. So on the first page of your homework, you've got 2 translations and 2 rotations. Okay? You need to draw both of those, for all of those, you should draw the triangles first, and then, so I see both of them on there. Okay? Then, page 2, you've got a reflection in a line, a reflection in a line, 4 reflections in 4 lines. Okay? Then, on page 3, you are drawing, you have the point and its reflection. You need to draw in and give the equation of the reflection line on 8 and 9. You are drawing the reflection line and giving me the equation of it. Okay? Then in the last few, 10 through 13, there's the equation of a line. Give me the equation of parallel. What's my parallel relationship? Lines are parallel when the...
What?
Lines are parallel when the slopes are the same. And the perpendicular slope. What's the relationship for perpendicular slope? Both of them, right? Opposite and reciprocal. Okay? Have at it.